Hello and welcome back to the course on operations management. Today we are going to learn about transportation models in the operations management. So, transportation model are the special kind of linear programming model which are being used for transporting goods from one place to another place. So, goods are being produced at the production center, you name it as a factories where goods are being produced, and then goods are being supplied to the demand center, which we name it as a warehouse or the distribution center. So, we transport goods from one place to another place, and whole objective of this model is to minimize the total cost of transportation. This model is also being used for taking a very strategic decision where to locate a production facility or our warehouse. So, this model is a very useful tool for the strategic thinkers when they are going to talk about setting up a new facility or new production plant of an organization. So, in the transportation model, to take the decision, how we take the decision, so that we are going to learn by using first a method which is named as northwest corner method, and then we are going to apply the better method than that is a least cost method, and then Vogel approximation method, which is commonly known as VAM. And to test whether this solution which we have obtained is best or not, we are going to use Vogel approximation method as well as a stepping stone method. So, but I will restrict myself to explaining one model only for this particular module. You may go for the advanced module for the learning the other method. So, we are going to learn this model with the help of an example, and the example I am taking is of a case study of a ordnance factory. So, ordnance factory has three production plants, first at Durg, second is at Etah, and third is at Fatehpur, and they are going to transport these goods from this place to the three army headquarters positions, which are named as Agra, Bikaner and Chandigarh. The production capacity of the factories at Durg, Etah and Fatehpur are 100, 300 and 300 units respectively, and the demand at the various destinations is 300, 200 and 200, that is Agra, Bikaner and Chandigarh respectively. So, production factory at Durg can transfer goods from Agra, Bikaner and Chandigarh without any restrictions. The only difference is they are having a different cost. Same way Etah can also transfer to Agra, Bikaner and Chandigarh, as same way Fatehpur can also transfer to Agra, Bikaner and Chandigarh. There is a cost difference is cost of transportation, but production cost at all three units are same. We are going to convert this model into tabular form, but before that we need to know what is the cost of transportation from one place to the another place. So, here we have on this side of the table we are writing in the row side, that is Durg, Etah and Fatehpur, the factory units from where I am going to transfer my product, and on the columnar side I am going to write to the places, the demand center where I am going to transfer the goods, that is Agra, Bikaner and Chandigarh. So, I am going to write now what is the cost of transportation from Durg to Agra. So, cost of transportation is 5 per unit, here is 4 per unit, here is 3 per unit, and here is 8 per unit, and here is 4 per unit, and here is 3 per unit. And from Fatehpur to Agra the cost is 9, 7 and 5, and total cost for the total capacity which is available at the Durg unit is of 100, and then at Etah it is 300, and at Fatehpur it is 300. So, this is the total capacity which is available for us, and what is demand for the Agra, which we discussed already, it is 300, it is 200 and it is again 200, and what we have to check is now total demand should equal to total capacity. That means 300 plus 200 plus 200, that is 700, and same way this should be equal the total supply, that is 100, or capacity, that is 100 plus 300 400 plus 400 plus 300, that is 700. So, here both demand and supply are equal. So, we say this is a balanced problem. What will happen if it is not equal? If doesn't come equal, what should we do? That means it is an unbalanced problem. So, how we can resolve that unbalanced problem? So, we will see whether total demand is less or whether total supply is less, whichever is the short. So, whatever is the short, we are going to add that the shorter amount, that is the amount by which is getting lesser. Let us say here it is coming 600 from this side and here it is total supply is coming 700, it means 100 is a shortage. So, it means we need another demand center because demand is less, and same way if supply side is getting shorter, demand is more. So, we need another supply center. So, we are going to create that supply center with that much remaining amount. One thing which is very important, now what will be the cost of transportation? Because we are just do not have actually a demand or the supply available. So, it is a dummy demand or supply which we have created. So, for transportation of goods, cost from one place to another place will be 0. So, we are not going to have any cost. That is way how we resolve an unbalanced problem. Now, let us solve this particular problem with the help of transportation model. So, in the transportation model, after fixing this, putting into this tabular form, we need to go for another thing, that is called, we are going to get an initial feasible solution for this particular problem. So, how we will get an initial feasible solution? So, we are going to use a method which is named as northwest corner method. So, this is the northmost corner of the approach. I am going to use very systematic approach for this particular thing. Here is my total supply available, here is 100. What is demand here? Demand is 300. So, what I can, how much maximum I can supply? I can maximum supply 100. So, I will take this as a 100 and make this as a 0, and this will be the remaining amount which is a demand available still at this particular point. Now, so if this becomes 0, I will cross this particular line so that I should not go on that side. Now, where should I go? I will go on this side. Here, how much is the demand now? Demand is of 200 and supply available is 300. So, how much maximum I can supply now is 200, left here is 100 and this becomes 0. So, whichever side is becoming 0, I am crossing it. So, this becomes another cross area. Now, where should I move further? So, I will be moving on the other side. Now, what is the other side we are going to move? How much is the demand available now? Demand is 200, but supply is 100. So, I can maximum supply 100. So, this becomes a 0 and here is left is 100. Now, if this becomes 0, this area is closed. So, now I will come to the other side. How much is the demand? Demand is 100, supply is 300. I can supply only 100 maximum. So, this becomes 0. Here left is 200 and finally, now I will reach to this particular column where I will be having a both demand and supply is equal to 200. So, this becomes 0, this also becomes 0. Now, after obtaining this doing say what we have obtained, how much goods we are going to transfer and what is the price for transfer, that is the cost. So, how much is the cost which we are having? So, 5 per unit we are transferring 100, that is from Agra to Durg, that is this is 5 into 100 plus we are going to transfer from Etah to Agra 8 at 8 per unit and units are 200, and same way 100 unit from Etah to Bikaner, that is 100 into 4 plus 7 into 100 plus 5 into 200. So, that is what I am going to transport the goods from one place to another place. Let me see now what is the total cost, rupees 4200. So, that is the total cost of transportation with this is the initial feasible solution which has been given by northwest corner method. So, what is the limitation of this particular method? The limitation of this particular method is we are not considering what is how much goods are being going transfer from another place, but we have not, while doing that we have not considered the cost of transportation. we just consider demand and supply constraint. So, friends, whether this is the optimal solution or not, that we will check later on. So, now we are going to learn the next model, which is called least cost method. So, in the least cost method, we will see into the cost matrix what is the minimum cost. So, minimum here is 3 and 3, these are two places where the cost is minimum. So, what is my objective? My objective is to transport the goods total cost at the minimum. So, I want to transport maximum with the minimum cost. So, how much I can transfer from here to here? So, here I can transfer 100, and on if I go for this particular 3, I will able to transport 200 units. So, I will choose this particular one, that is 200. So, this becomes 100, left here is 100, this becomes 0, and this section is crossed. Now, we will take step, move further and see from the remaining cells what is minimum. Now, the remaining cells minimum is 4 and another 4 again. So, how much I can transport now? From here I can transport 100, from here also I can transport 100 only. So, there is not going to be much difference which is going to make. So, I can transport anyone, let us choose first one, I take this becomes 0 and here left is 100, and now if this becomes 0, this will be gone from the remaining cells. Now, what is minimum? This is minimum. So, I am going to give this also 100, this becomes 0, this becomes 0, and now when this becomes 0, this is also crossed and this is also crossed. Now, what is remaining is this particular cell, how much I can transfer is 300, this becomes 0, this also becomes 0, and finally, I have been able to transport whole of my goods. And let us calculate what is my total cost. Total cost of this will become 4100. So, my total cost, we can see from the previous model, the total cost was 4200, now the total cost is 4100. That means with the new model I am able to reduce my cost, that is a better model is in place. So, thank you friends.